Next, we have the third formula for this chapter. So to find the areas of a polygons, we are going to start by drawing a triangle with three vertices here. Each of these we label A, B, and C with x1, y1, x2, y2, and x3, y3. Then we are going to draw a straight line and a horizontal line to join all the A, C, and B at point D and point E. So first, we find the area of the triangle here, and we then find the area of a trapezium, and after that we minus the triangle here in order to find area of the green triangle. Okay, so we start off by finding the area of a triangle ADC, and then we add the area of a trapezium CBDE. Then we minus the area of a triangle ABE. Area of a triangle ADC here can be found by using 1 over 2 times the base length, which is AD, times the height, which is CD. Then the area of a trapezium can be found by using 1 over 2 times the height, DE, multiplying the total of the two parallel sides, CD, the sum of CD and BE. And then the area of ABE will be this one, will be 1 over 2, the base AE and the height BE. AE and the height BE. Now we need to convert all of this into x1, y1, x2, y2, x3, y3. Then we have this AD. To find the length of AD, we look at, since it's a horizontal distance, we only look at the x1, this is x3, and this is x2. So AD is x3 minus x1. CD will be the vertical height. Then we have a y3 here. All this is y3, and here we have y1. Okay, here we have y1. So y3 minus y1. For DE, we have x2 minus x3. For CD and BE, we have CD will be same, y3 minus y1. BE will be this one, will be y2. This is your y2. Okay, BE, y2 minus y1 plus y2 minus y1. So this part, since I don't have enough space here, I'll write at the next row, 1 over 2 AE. From A to E, it will be x2 minus x1. BE, again, it will be y2 minus y1. Okay, so we have 1 over 2 here. So since 1 over 2 appears for all the terms here, we can factorize it. Then this one, x3 times y3, you get x3 y3. x3 times negative y1 minus x3 y1. And here, this minus will apply to all the terms inside here. Now we try to simplify everything. Okay, so we see that x3, y3 will be deducted by here. So this is gone. x1, y1 is deducted by this, and this is gone. x2, y2 is deducted by this is gone. Negative x3, y1 plus 2x3, y1. So you are left with 1x3, y1. This one is still here. Plus 1x2, y1. You get negative x2, y1. Then minus x3, y2 and plus x1, y2. And now you rearrange this such that it satisfies the given formula. Okay, if you look back at the formula, it starts by s1, y2, s2, y3, x3, y1. So you have x1, y2, x2, y3, x3, y1. If we refer to this, it is negative, and then the whole three terms here. So we have a negative here. You have this. And hence this is as the formula given. Then we have areas of quadrilaterals, which I'm not going to show in this video, but I'll explain how you do it. First, you divide the quadrilaterals into two triangles. Hence, you find the area of ADC, this triangle, and you find the area of the triangle ACB by using the same step that I did just now for both of these. And then you combine all the terms so that it matches the formula that is given. Now we move on to the next chapter. We move on to chapter 9, solution of triangles, where we need to verify conjectures between the length of the sides of the triangle and the opposite angles, which is sine rule. To verify sine rule, we need to refer to these two triangles. This is an acute angle triangle, and this is an obtuse angle triangle. Notice that we label the vertices ABC, ABC, and the opposite sides of angle A will be the small letter a, and so on. Then before we start to verifying the sine rule, we draw a straight line from here to here, which is the height of the triangle, and it is 90 degrees here, and we label this as H, and this point here as point D. For an obtuse angle triangle, we draw a straight line, a vertical straight line, which is 90 degrees to the base here. And we also label this as H. And the point here will be point D as well. Okay, so to start, we are going to consider this angle. And we want to find sine B, or the sine of an angle CBA. Okay, so for angle sine B, it is equals to, according to the definition, sine of angle B equals to the ratio of the opposite side over the hypotenuse of this triangle. We are now referring to this triangle, the BCD. Opposite side here is H, the hypotenuse is A, and H of A equals to sine angle B. Remove the A here, you get H equals to A sine angle B. Notice that this is the same for the triangle at the right, because the angle sine B here, is equals to the sine of this angle, which we'll learn in trigo, where the sine of the angle here is equals to the sine of its reference angle. Okay, so sine theta is equals to sine alpha. Hence, sine of this big angle here is the same as sine of this angle, which is also equals to the opposite side, which is H, over its hypotenuse, which is A. So this equation here can be applied to both triangle. Now, we look at the next angle, angle A, sine angle A. If we refer to this angle and this triangle, ACD for this triangle, sine angle A is equals to the ratio between the opposite side, and the hypotenuse. The opposite side is h, hypotenuse is b, h over b. Likewise here, angle A, h over b for this triangle, ACD. Then we have h over b equals to sine of angle A, h equals to b sine angle A. Since h is the same for both, the height is the same, then we can let A sine angle B equals to B sine angle A. And if we move the sine to the other side, you will have the formula. A over sine angle A equals to B over sine angle B. Or if you want, depends on the question, you can have sine angle A over A, which equals to sine angle B over B. Next, we have 9.2 cosine rule. For cosine rule, we are going to use this triangle similar to the sine rule, where you draw a vertical straight line which is 90 degrees or perpendicular to the base BC, and this point here, label it as D. So since this is the height of the triangle, we label this as H, and we can use small letter a to denote BC. And to verify this cosine rule, we will let BD to be x, hence DC will be A minus x. A minus x. We now first consider the triangle ACD, this triangle. Since it is a right angle triangle, we can use Pythagoras theorem to relate h, a minus x, and b. So the hypotenuse squared equals to the sum of the square of the other two sides, which is h squared plus a minus x squared. Expand this, you get. Then we move on to this triangle here, ABD, where you also have a right angle triangle and the hypotenuse is c. So we let c squared to be h squared plus x squared. From here, we want to have h squared in terms of c squared and x squared. So I'm going to write h squared plus x squared equals to c, and h squared equals to c squared minus x squared. And I'm going to substitute this into here. Substitute this into this. By letting this to be equation number 1 and this equation number 2, I'm substituting equation 2 into equation 1. So I'll get b squared, which is equals to c squared minus x squared plus a squared. And we further simplify this, you get b squared equals to c squared plus a squared. Since this and this cancel off, minus 2ax. Then we still have an x here, which we are going to relate to the cosine. So we refer to this triangle again. You see that if we take the cosine of angle B, cosine of angle B, this is equals to the ratio of the adjacent side over the hypotenuse, which is x over c. So from here, we can say that x equals to c cosine angle B. Hence, we are going to substitute again this into this. You get b squared equals to c squared plus a squared minus 2ac cosine B. Find that this and the equation given here is a bit different, but you can change the label here according to the equation, meaning that you still can change all this according to the diagram that is given. Then we have the last formula for Form 4, the area formula of a triangle. To derive this formula, we need the triangle again. Similarly, you need to draw the height, which is denoted by h. And we are going to use the basic area formula for a triangle, which is 1 over 2 times the base length times the height, which is your h here. So the base length here is actually AC, or also denoted by the small letter b, where the height is h. Then we are going to consider this triangle here. For this triangle, if we take the A angle, so the sine of angle A is equals to the opposite side, the length of the opposite side over the length of the hypotenuse, which is h over c. And h is c sine angle A. So we are going to replace the h here, substitute this with this, and h it becomes c sine A. And again, you can adjust this such that it match the formula or the diagram which is given during the exam. Hence, these are all the formulas from Form 4. I hope to see you in the next video where I'll be deriving the formulas for all the chapters in Form 5.